Hi, Pre-Calculus. I am going to walk you through problems 13, 14, 15, and 16 from the 1.4 homework. All right, so I showed you a way to do problem number 13, but I'm going to show you the other way because when you have problems like number 14, the second way to do it is a little bit faster. So, what we do when we're getting ready to do this problem, we're going to set our, whatever's inside of our absolute value sign, we're going to set it equal to 0 and solve for x. Then we're going to make like a number line and put that number there. Then we're going to take a value that's to the left of it, and I'm just going to say, what if I put a 2 in? And I'm going to imagine if I put a 2 in right here, is my number going to be positive or negative inside this absolute value sign? And so you can see that if you put a 2 in, you're going to get a -1. So that -1 times the -2 is going to give you a +2. So for x equal 2, well, maybe I should put it on this side since it is on the left-hand side of the number line. For x equal 2, we would have a -2 times, and then this is going to end up giving us a negative value, right? We said that that if we put a 2 in, that this whole thing would give us a negative. So we have to imagine that that negative is going to come out making that 2 positive. And so this is going to end up being 2x minus 6 plus 5, 2x minus 1. So that gives you your function, your piecewise function, for everything less than 3. Okay? If I pick something that's greater than 3, like a 4, I'm going to look at x equals 4. That would give me a positive value. So that means that I would keep that as positive x minus 3. And then simplify. That one gives me everything to the right of 3. So negative 2x plus 11 for everything greater than or equal to 3. And so now I know that 3 is where they change. They're going to share that. So what is f of 3? Well, if I put a 3 in, I get 5, right? Now, coming in the other way, 2 times 3 is 6 minus 1 is 5. When they switch, they stay continuous. So I've got the point 3, 5 that I know they both share. So everything to the left of it is going to be 2x minus 1. So I know that I have a positive 2 slope. So I'm going to go down 2 and left 1. To get my positive 2 slope. Down 2, left 1. Down 2, left 1. Down 2, left 1. Okay, so that gives me my positive 2 slope. And that's everything less than 3 is 2x minus 1. And then -2, +1. -2, +1. -2, +1. -2, +1. That's my -2 slope. I went down 2 and right 1 to get that one. And this line is the line -2x plus 11. But we only care about this piece of it for everything greater than 3. And we have just graphed our function. So the reason why this works out nice for when there's 2 absolute values is because you have 2 things that you need to focus on, 2 points that you need to focus on the number line. So I'm going to put my x plus 2 equal to 0, I get x equals -2. I'm going to put my 2x plus 6 equal to 0, 2x equals -6, x equals -3. So when I draw my number line, I've got -3 and 2. Oh, I'm sorry. Oh, no, I did that right. I thought it was a positive 3. Sorry. It was a -3. Okay, so -3 and -2. And you want to put them as they are on the number line so that the -3 is to the left of -2. And now you're going to choose a value that is less than negative 3. Oops. Like negative 4, let's say. Okay? Erase that. Sorry. I kind of hit my iPad. So let's choose negative 4. So for x equals negative 4, if we were looking at our values, when I put negative 4 into my x plus 2, it turns it multiplies it by a negative. Okay, so that means that this would be negative x minus 2. When I put negative 4 into the next one here, this one gave me a negative. This one's also going to give me a negative. So I'm going to distribute that negative. And that gives me negative 3x minus 8. So I know in my piecewise function, negative 3x minus 8 is going to be what I use for x less than, and you could, decide whether you want to do less than or equal to or whatever. Let's just go ahead and do less than or equal to negative 3, okay? Because, this is your, these are your stopping points, right? Those are your zeros there of those individual functions. And so I chose as a test, this was my test point, x equals negative 4, and I was testing it for all values that are less than negative 3. And it's going to be, this is going to pertain to all values less than negative 3. This is the function that it's going to be using. Now, there's not a lot of space in between these two, negative 3 and negative 2. But we could do negative 2.5, which is negative 5 halves, or whatever, however you want to do it. And then let's look if our test was negative 2.5 for everything in between, do I get a negative or a positive up here? So if I put a negative 2.5, I'm going to get a negative on the x plus 2. And so that's going to be, I'm going to distribute that negative x plus 2. Oops, didn't distribute. Negative x minus 2. And then when I put a negative 5 halves, it's easier to use negative 5 halves on this one because the 2's cancel and you get negative 5 plus 6, and so you get a positive value. So this one's going to stay positive, so positive 2x plus 6. And so then add your x's, you get positive x, positive 1x, add your whole numbers, you get, or integers, you get positive 4. And so we know that in between negative 3 and negative 2, we have the function x plus 4. And so this is, we already used up our equal to, so we won't put an equal to on there. But this is for those values. And I'm going to just erase that little piece right there. Put my back in. This was our test in between. That was our test number. But there's that second part in between negative 3 and negative 2 for our piecewise function. Now we're going to do a test greater than negative 2. So let's say negative 1, you could even use 0. It could be any number greater than negative 2. Okay, so that's going to be our test. We're going to use our test negative 1. Well, if I put a negative 1 in right here, I get a positive. So that's going to give me x plus 2. If I put a negative 1 in for the second one, 2 times negative 1 plus 6, I get a positive. So that one's going to stay the same, positive 2x plus 6. I add my like terms, I get 3x plus 8. So the third part of my function, 3x plus 8, is for x greater than or equal to negative 2. So that's going to be for that piece of the function. So I've got my piecewise function. Now I'm going to go graph it. Okay, so this is when I would probably use my chart like I showed you the other day. So this is less than or equal to negative 3, so negative 3, negative 4. You only need a couple of points. You know it's linear. And this is your negative 3x minus 8. Okay, so if I put negative 3 in, I get 1, because that'd be positive 9 minus 8, 1. If I put a negative 4 in, I get 12 minus 8, 4. And so negative 3, 1, and negative 4, 4. And so you can see that it's going to be going this way, right? That's that piece of the function. Now, the next piece of the function is just in between negative 3 and negative 2. So negative 3, negative 2, that's my x value. My y is x plus 4. So if I put negative 3 in, I get 1. If I put negative 2 in, I get 2. So they always share that same point. So there's that negative 3, 1, negative 2, 1, 2. Right now, I'm going to have like an open circle, but I'm not even going to put an open circle there, because I know that it's going to get taken up by this other function, because these are continuous functions. They won't have a jump discontinuity. Negative 2, negative 1, 0, because I'm going greater than negative 2. And so negative 6 plus 8 is 2. So you see how they share that point? Negative 2, 2, negative 2, 2. Negative 3 plus 8 is 5. And this is 8. So let's go ahead and graph that. So we said that they share that negative 2, 2, negative 1, 5, 0, 8. And so that's supposed to be straight. I'm having a little bit of trouble drawing a straight line there. But you guys could use like a your ID or a ruler or something, your driver's license, and draw that straight line. But so it has 3 different functions that it's on. It goes, it has this negative slope, and then it has this positive slope going like right there, and then a steeper positive slope. Okay, so oh goodness. Make sure that you can see that on your graph. I just kind of messed mine up a little bit. Okay, so now that's it for that one. So now, problems 15 and 16. For what values of a and b will the function be continuous everywhere? Well, this is a quadratic function all by itself. So if this was the only function, it would be continuous for all x values. This is a linear function, or actually it's going to end up being, like a horizontal line. And it's going to be continuous all by itself everywhere. The place where we have to worry is where they change functions, and it's changing at 2. So that's where we need to worry. So the first thing we're going to think about is, what is f of 2? Okay, well, that's where the equal to sign is, so I'm going to follow that, and I'm going to say, well, f of 2 is 2a plus 1. Okay? Then I'm going to say, well, what is the limit as x approaches 2 from the left for f of x? And so then I say, well, and you guys, oh my gosh, I'm doing the calculus version of this because you really haven't done limits yet. So let's just erase that and say that if our ax squared minus 3x is equal to our 2a plus 1 at 2, so at x equals 2, this would be a times 2 squared minus 3 times 2 equals 2a plus 1. Okay, if they are equal, if they share like this one did, shared the same point, right? Remember this one up here? We said that this one and this one shared the same point, and then we said that the next two shared the same point. That made it continuous. If they hadn't shared the same point, it would have been a jump discontinuity. So we want to make sure that when these two change at 2, that they share the same y value. So this is like the y value of the ax squared minus 3x. this is the y value of the 2a plus 1, right? That's the y value. And if we put x equals 2 in, we're wanting them to share where it changes here at x equals 2. We want that to be the same. So that's going to give us 4a minus 6 equals 2a plus 1. So now I can subtract 2a from both sides, and I can add 6 to both sides, because that gets rid of the a's from that side. It gets rid of the numbers from that side. And it gives me 2a equals 7. So if my a is 7/2, this function will be continuous. And let's just look at what it would be. So we've got 7/2 x squared minus 3x for x less than 2. And if I multiply the 2 by my a of 7/2 plus 1, the 2's could cancel there. This is going to be 7 plus 1, which is 8. So remember how I said it was going to be a horizontal line? That's what we end up getting, 8 there. So it's just y equals 8 for x greater than or equal to 2. So how does that work? Well, here's where it changes, right? So you've got, 1, 2, 3. At 2, I know that, let's go ahead and, let's go by 2's. 2, 4, 6, 8. That it's going to go like that for everything greater than or equal to 2. And now that I've put the proper, 7/2 x squared minus 3x, I'll just check to make sure I get 8. So if I put a 2 in, 7/2 times 2 squared minus 3 times 2, one of those 2's is going to go away with one of those. So this is going to be 14 minus 6. That is 8. So they share that point. And then what do I get if I put a 1 in? 7/2 times 1 squared minus 3 times 1. So 7/2 minus, I'm going to make my 3 6/2. So that's 1/2. Okay, so that's going to be way down here. So 1/2 comma 1. I mean 1 comma 1/2, sorry. And then when I put 0 in, I get 0. And then when I put -1 in, so 7/2 times -1 squared minus 3 times -1, I get 7/2 plus 6/2, which is 13/2, which is almost 7. So -1, I don't know. So you can't really tell from here where your vertex is, but I'm thinking it's like that. Sorry, but that is the function that we're talking about. And that's what the graph looks like. Notice that it stays continuous there because they shared that y value where it changed functions, okay? So for this one, it changes in 2 different spots. So we have to look at where it changes when x equals -3 and when x equals 2. So I'll do x equals 2 in a different one, different color. So for -3, we're going to say, well, we want the 2x plus 5, which is on the left-hand side of -3, because that's less than. We want that to equal ax plus 5b, okay, when x is 3, or -3. So now I say, okay, these need to equal each other at this x value. So -6 plus 5 equals -3a plus 5b. So -1 equals -3a plus 5b. Okay, so we've got that. Okay, let's just put a box around it and let's figure out the other one. because we got two unknowns, so we need something else. I'm going to erase this right here. Okay, so now, when x is 2, to the left of it is ax plus 5b. To the right of it is x squared minus 2x plus 3. Okay, we only need them to equal when x is 2. That's the only time we need them to equal each other, okay? So that's going to be 2a plus 5b equals 4 minus 4 plus 3. Well, 4 minus 4 is 0. So 2a plus 5b equals 3. There's my second equation. Now, I want this all to happen at the same time. So what I'm going to do is I'm going to say, if I solve these simultaneously using substitution or elimination, I can get continuity for all of them, okay? For at -3 and at 2, because I want this to be completely continuous, not just continuous at -3 or just continuous at 2. I want them continuous at -3 and 2. So I'm going to take those two equations and solve by substitution or elimination. Okay, so we're going to solve by substitution or elimination. I'm going to go ahead and use elimination just because it looks like I can easily do that. If I multiply the top equation by -1, I'm going to get positive 3a, negative 5b equals positive 1. And then I'm just going to rewrite my second equation and add them together. You can see my b's will be eliminated. This will be 5a equals 4, and my a is 4/5. And then once I get my a as 4/5, I can then put my 4/5 back into one of my equations. I just chose this green one right here. So I'm going to say 2 times 4/5 plus 5b equals 3. So 8/5 plus 5b equals, I want to change my 3 into fifths. So I take my 3, I multiply it by 5, and then I put it over 5. So 15 divided by 5, is that 3? Yes. So 15/5 is 3. Now I'm going to subtract 8/5 from both sides. 5b is equal to 7/5. And so I multiply by 1/5, multiply by 1/5, and my b is 7/25. So if I make my a 4/5 and my b 7/25, I will have a g of x up here in problem number 16 that is continuous at -3 and continuous at 2. And we could, put those back in if you want to look at, how it would work. Your 2x plus 5 would stay the same because it doesn't have an a or a b in it. But this one would be 4/5 x plus 5 times 7/25. Okay? And that would be from -3, not inclusive on the 2, to 2. And then the next one is x squared minus 2x plus 3. So really the only one that had the a and the b in it was that middle function. And we could say divide by 5, I get 1, divide by 5, I get 5, so this becomes 7/5. So if you wanted to graph it, 1, 2, 3, there's your -3, less than -3. Well, you've got -6 plus 5 is -1. So here, technically we'd have an open circle because it doesn't have an equal to sign. And if I did -4, because I know I'm going less than, I would get -8 plus 5. That would be -3. So this is going to be a linear function going that way. And then between -3 and 2, you would have the 4/5 x plus 7/5. So, let's go ahead and write that, 4/5 x plus 7/5. So at -3, if I put a -3 in here, it's going to be -12/5 plus 7/5. And that's going to be -1. So that hole is clogged up now, or plugged up. That means it's continuous. And then at -2, you'd have a -8/5 plus 7/5, which would be -1/5. Oh my gosh. And then at -1, you'd have -4/5 plus 7/5, which would be a +2/5. These are tiny, tiny, tiny y values there, but, and at 0, you'd have 7/5, which is a little bit more than 2/5 more than 1. So you can see that, and by golly, my graph is terrible. Sorry about that, but that would just be, oops, it only goes to 2 though, doesn't it? And at 2, what would you have? You would have 8/5 plus 7/5 is 15/5, which is 3. So yeah, this is my problem, this y value, because this at 2, that would have to be 3, a y value of 3. So anyway, just kind of ignore my, here's 1 and 2, let's say, or well, no, 2 would have been up here. There's 1 and 2. So there's your little piece there, and then for that last part, it's a quadratic, but I bet at 2, it's going to have a y value of 3, so that's 4 minus 4 plus 3. Yes, it does. At 2, it has a y value of 3. Then at 3, it would be 9 minus 6, which is 3, plus 3 is 6. So at 3, I would go up to 6. And then at 4, it would be 16 minus 8, which is 8 plus 3 is 11. So at 4, I'd be way up here at 11. So you can just imagine that that would go like that. So it goes right into a quadratic function, but there is no discontinuity. They're all connected, even though it's 3 different functions. Okay, and you didn't have to do that graph. I just wanted to show you how it worked. You only had to create these two and then find your A and your B. Okay, I hope this helped.